Good evening. Well, we've made it to lesson 4, and lesson 4 is about multiplication and division and a new word that you may not have heard, algorithm. Let's talk about the multiplication for just a second. Multiplication is really just repeated addition, because instead of having to say 4 plus 4 plus 4 plus 4 and continue to think about that in your head, you can say 4 times 4 and know that that is 16. You can do that quickly if you memorize your multiplication facts, and if you use them often, you'll find that it's much faster than addition. Now, we talked about inverse operations. Division is the inverse operation of multiplication. Knowing your multiplication facts also helps you to solve division problems quickly. Have you picked up on the fact that I think knowing your multiplication facts is incredibly important? Alright, let's talk about algorithm. An algorithm simply is a big word that means a way of doing something. This is something that I want to see in your notes. When I check your notebook, I want to make sure that you have this definition, because you'll hear this word probably again, at least at some point in your life, and I want you to know what it means. It's a way of doing something. Sometimes it's thought of as a pattern of doing something, a method. Now, what we're looking at here is called the long division algorithm. And we can also say the long division, the steps of long division. And we know that there are certain steps that we have to do. The first thing we do is divide. And in this particular problem, we would say 25 would go into 27 one time. And then we multiply. 1 times 25 is 25. Then we subtract that from the 27, leaving us with 2. After you subtract, you bring down the next number on the right, and then you start that algorithm all over again. You go back and you divide again, and then you multiply, then you subtract, and then you bring down. Now, I cannot tell you how important it is that you know this process along with your multiplication tables as you move next year into the Algebra 1 book, because you're going to be more deeply into abstract numbers, which is and concepts, things that don't always, you can't always put them into a calculator and figure them, because they are simply letters that stand for variable numbers. But if you know the process, you can still do these operations with long division, fractions, addition of fractions, multiplication of fractions, those kinds of things. So that's what algorithm is. Now let's go ahead and look at our practice problems. The first practice problem says 300 times 125, and we could do that in the standard algorithm. We could say 300 times 125, and we could do it that way. But I think that a simpler way of doing this would be to say 125 times 3, and do that. That would be 3 times 5 is 15. I'm going to carry that 1. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. So 375. But I'm not really multiplying by 3. I'm multiplying by 300. So I'm going to need to put those 2 zeros on at the end. But don't you think it's easier to just do this? Let me add a little bouncing ball. To just do it this way as opposed to this way, I think it's just so much easier. Alright, let's go on to practice problem B. Now, unfortunately, in this one, there is no shortcut or little trick that I can tell you, but we're going to just go ahead and do the the steps that we need to do. Starting with the 3, we will say 3 times 8 is 24. Carry that 2. Sorry there. 3 times 7 is 21 plus 2 is 23. Carry another 2. 3 times 7 is 21 plus 2 is 23. Now we're going to put a placeholder in. 6 times 8 is 48. Carry the 4. 6 times 7 is 42 plus 4 is 46. Carry another 4. 6 times 7 is 42 plus 4 is 46. Now for this last one, because it is in the because this 6 was in the tens place, I added this 1 0. But because the 5 is in the hundreds place, I'm going to come over and add 2 zeros to the end of my final number. Okay, and that's why you do that. Alright, 5 times 8 we know is 40. Carry that 4. 5 times 7 is 35, plus 4 is 39. Now we're going to carry a 3 up here. 5 times 7 is 35, plus 3 is 38. And then we have to add all of that. 4, 0, 0 is 4. 8 plus 3 is 11. 3 plus 1 is 4, plus 6 is 10. 9 plus 1. I always want to do your combinations of 10. That makes it a little easier to add when you've got lots of numbers. So 9 plus 1 is 10, plus 6 is 16, plus 2 more is 18. 8 plus 4 is 12, plus 1 is 13. Carry that 1. And then I'm going to go ahead and put my comma in. And there you have the answer. Let's go to the next practice problem on the next slide. Alright, now here we have a multiplication problem that is a little bit, it's written a little bit differently. So in this one, I'm going to take my old standby because I've got a number with a 0, and I'm going to say, let's say, I can either do 19 times 2 or 21 times 2. Let's go ahead and do the 19 times 2. And 19 times 2 is 38. And then I'm going to put that 0 on. And then I can say 38 times this 21. 1 times 0 is 0. 1 times 8 is 8. 1 times 3 is 3. And then I'm going to put that 0 because that 2 is in the tens place, so I need a 0 there in the ones. And 2 times 0 is 0. 2 times 8 is 16. And 2 times 3 is 6, 7. Then I'm going to add 0, 8, 9, and 7. Put my comma in after the every 3 numbers, 7,980. Alright, let's go to D. Alright, I want you to understand in this lesson, we've got division written 3 separate ways, but they all mean the same thing. This fraction bar right here in the middle, what that means is divide. So what we're going to do is divide 30 into 261, or you would say that 261 divided by 30. Alright, now I can't, 30 won't go into 26 because it's bigger, so I'm going to have to say 30 into 261. When you have big numbers like that, sometimes it's easier to estimate and just kind of guess. If I say 3 will go into 26 how many times, that will get me close. So 3 will go into 26 8 times. And I'm going to try that. 8 times 0 is 0, and 8 times 3 is 24. And I believe I'm going to have a right answer there. I'm going to subtract because I divided. Sorry. I divided, then I multiplied, then I subtracted, then I brought down. Well, I'm not finished subtracting yet, but you get the picture. And there's nothing to bring down in this one. So I've got 8 and 21 over 30. But for those of you who do know your multiplication facts, you should see that this can be reduced because 3 will go evenly into 21 and 30. So I'm going to say 8 and 3 goes into 21 7 times and into 30 10 times. And this would be my final answer. On to the next division problem. Alright, in this one we're going to say 12 will go into 49 how many times? So the first step is divide. Well, it goes 4 times because I know that 4 times 12 is 48. So I multiplied, I divided, I multiplied, I'm subtracting, I get 1, and then I'm going to bring down the next number on the right, and that is 10. Well, 12 won't go into 10, so I'm going to have to put a 0 in that place, and then I'm going to have to bring down the next number, 108. Now, challenge, if you know your 12 tables, you would know how many times 12 will go into 108 because it will go an even amount of times, I do believe. Let's see, 12 times 10 would be 120. 12 times 9, yep, that's it. 9 times 2 is 18. Carry the 1. 9 times 1 is 9 plus 1 is 10. I'm going to subtract and I get a 0 remainder. And we're good. Alright, one more practice problem. Okay, for our last practice problem, we see that we've got yet a third division sign, and we're going to set this up like a division problem like we're used to. Sorry, I'm trying to speak a little bit louder. Alright, remembering our algorithm, 47 will go into 56 one time. I multiply, I get 47, I subtract. I'm going to have to regroup. 16 minus 7 is 9, and then I'm going to bring down to the 2. Now I would be tempted at this point to say that 47 will go into 92 twice, but I know that 7 times 2 is 14, and if I carry that 1, then that's going to be 94, so it is only going to go one time, and I'm going to get 47 again, subtract, and again I'm going to have to regroup. 12 minus 7 is 5, 8 minus 4 is 4, and then I'm going to bring down this 3, and I've got 453. So, sounds like a really big number, and oh my goodness, how do you do that? Well, if you put a 0 on the end of that 47, that makes it 470, which is divisible by 10. So 10 times 47 would be 470, which is just a little bit too large, so I'm going to try 9. 9 times 7 is 63. If I carry that 6, 9 times 4 is 36, plus 6 is 42. I'm going to subtract, and 453 minus 423 is 30, so I'm going to have a remainder of 30 over 47, and that would be my final answer. Good luck on this lesson. Take your time, do it well, and I will see you next time for lesson 5.